Welcome you students. I come up with the question from Centroid. The question is locate the centroid for the area shown in figure. So this is the figure exactly given. For this we are going to find out the centroid. So to find centroid, which is x bar and y bar. Okay. If you move to this solution part, the first step I said just bring it into the coordinate x y. So this is the exact diagram. I just going to bring it from the left extreme. I going to place it at oy, bottommost I just going to place it on the ox. So this is how the diagram is. Okay, so this is how the diagram is, and its measurement is given 7 centimeter length and height of is 12 centimeter, and its radius which is given, if I take its radius, it is given as 2 centimeter. Okay, its radius is 2 centimeter. That's all. And the next step, just break down or divide it into smaller components. Okay, so here if I break down it, I can say this rectangle is one component and this semicircle is the second component. Okay, two components. So first I just going to identify the self-centroid for the rectangle. So first it's a rectangle. So it's a easy question. So here bring it x, y, the measurements 7 centimeter and 12 centimeter. What about the x bar? X bar in the sense from the O to this particular centroid, right? This measurement is x1 and this measurement is y1. So from the O the object is, so exactly the self-centroid. Rectangle is b divided by 2, so here it is 7 divided by 2, we get 3.5 centimeter. Y bar, here as well from the O it is beginning, the object is, so here the self-centroid h divided by 2, so we get the 12 divided by 2, so that's 6 centimeter. What about the area? Area A1, area of rectangle, which is nothing but length into breadth, BH. So here 7 into 12, we get the answer as 84 centimeter square. Have you got it? What is next? The second one is a semicircle, not a circle, semicircle. Just locate it where it is. So x, y, this is O, somewhere here it is. This is how the semicircle is. And now we need to find from OH how far from it and from OY how far from it. That distance must be identified. So here comes from OX how long it is. Just see here the particular end to the the rectangle other side, which is given 12 centimeter. Okay, so if I take about the center of this the radius, something like this, I can say a distance is half of it, right? 6 centimeter. Okay, 6 centimeter. So up to this center is 6 centimeter. Then what about this particular? The radius of it is 2 centimeter. The radius is 2 centimeter. So if I minus 2 centimeter from this 6 centimeter, I will get the answer for this. So 6 minus 2, I will be getting 4 centimeter. The distance is 4 centimeter. What about the distance from OY? OY, this distance, how much it would be? The entire length is 7 centimeter. So if I minus 7 minus this radius, I will get this particular distance. This distance 7 minus 2, I will be get 5 centimeter. Okay, have you got it? Okay, this gap is between 5 centimeter. This is with the 4 centimeter. Now x bar is equal, sorry, now x2. Now it's a x2 equal to centroid from this to this particular point. So in order to identify it, just we need to or bring it to your mind how this position is. We actually learn the centroid formula for this position xy. This is the position. For this we learned the things x and y. For this x we just put here, it is diameter, so d divided by 2. Here when you come to y, here it is radius, length is a radius, so the formula is 4r by 3 pi, something like this I have been set you. So here the formula, here the position is just like this. So this is the position of the semicircle. If I put, it is just like this. So now see, this is the x here and this is the y, right? So now just keep it in your mind, for this position y bar is easy. Here actually from this end to end, which is d, diameter of the semicircle. So the d will be from O to this measurement. If I take this as centroid, this into this y will be, or y will be d divided by 2. D divided by 2, we will get the centroid when you are locating the y. When you are locating x, we must careful. We need to specify from this particular point to this. This is x. Okay. So we know from this particular end to this, I mean this diameter to this, which is here we have identified as 4r by 3 pi. Am I right? This measurement is here 4r by 3 pi. So what I going to do is here I just going to put r, the total measurement is r. Okay, this end to this is r. So from the r I just going to minus this particular portion. So r minus 4 r divided by 3 pi. So this is the formula here comes. In the introduction part itself I have given. So keep it in your mind when you are having the position change, just keep it in your mind, the formula will be somewhat altered. So please be aware of it. So here comes the x2, from this to this we need to find. So if I take this as a centroid, this measurement must be x2. So that measurement can be identified. First just take the gap, which is 5, plus the formula here we arrived is r minus 4r divided by 3 pi. Okay. Now if you substitute it, 5 plus r is 2 centimeter minus 4r into 2 divided by 3 pi. So if you put, the answer will be I hope you will get 6.15 centimeter. That's x2. Then y2 is easy calculating, which is diameter d. So what I going to do is, this gap is I have identified, which is 4 centimeter. So 4 centimeter. Now this gap we have put it 4 centimeter plus the answer, that means the self-centroid for this particular semicircle in y direction is d divided by 2. Okay, that gap plus the self-centroid. Here as well, the gap plus its self-centroid. Okay, fine. So 4 plus d is 2, sorry, diameter is 4. Radius is given in the question, which is 2, so the diameter will be 4 divided by 2. So here we will get 4 plus 4 divided by 2, we get 6 centimeter. 6 centimeter. This is y2. Okay, and A2, area of the semicircle. What is the area of semicircle? Circle area is pi r square. So of the of the semicircle, in the sense of the circle, right? So pi r square divided by 2. So what I get is pi into r is 2 square divided by 2. Here we get 6.28 centimeter square. Okay, this particular semicircle is a hole. It's a removed section or hole. Okay, it's a portion is removed. That's a removed. Which is removed. So centroid XPOR formula will be, we know it is nothing but sum of first moment of area about y-axis divided by total area, right? So here A1 x1 minus A2 x2. That is very important. It is a removed portion. It's not our part. This alone our part. So from the rectangle we just going to minus this. So here A1 minus A2. So what would be the update here? The A1 is 84 into 3.5 minus A2 6.28 into x2. Here we have got 6.15. Okay, divided by 84 minus 6.28. Okay, so I hope you will get 3.28 centimeter, which is x bar. Y bar answer, in the sense sum of the first moment of area in the x direction divided by total area. So here the formula will be A1 y1 minus A2 y2. Removed section, so minus A1 minus A2. Here the formula will be A1 is 84 into y is 6 plus minus A2, which is 6.28, the y2, which is here, into 6 divided by 84 minus 6.28. We get the answer for XPOR 6 centimeter. Okay, the next is a result. After finding it, we have to plot the result. So this is how the diagram is. This is x and this is y. Okay, this is O. The entire length is 7. Here in the x-axis, which is 3. So in between it, I just going to mark the x measurement, x bar. Okay, y bar, which is 6 centimeter. The entire length is 12. The right center of the object, I just going to plot the y bar. Okay, so I hope you understood how to work, in which procedure we need to go with it. Divide the components into simple components, and afterwards just identify each and every individual self-centroid and areas. Afterwards find out the centroid using the formula x bar is equal to sum of moment of the first moment of area about y-axis divided by total area. For the y bar, sum of first moment of area about x-axis divided by total area. Okay, so when you are putting it, you will get x bar is equal to 3.28 and y bar 6 centimeter, and afterwards locate the result with the help of x bar and y bar where the point C is. Okay, I hope you understood. Thank you so much.